Namaskar, I am Anand and all of you are watching Join for Education. In this class, I am going to solve six numerical problems of mechanical properties of solid of NCERT textbook. Let's see the question. All of you are seeing the question in your screen. So this is the question number 11 of the chapter 8. A 14.5 kg mass fastened to the end of a steel wire on a stretched length 1.0 meter is whirled in a vertical circle with an angular velocity 2 revolution per second. At the bottom of the circle, the cross-sectional area of the wire is 0.065 centimeter square. Calculate the elongation of the wire when the mass is at the lowest lowest point of its path. So after there is no problem to understand the question. To solve this question, first of all, we prepare a data and according to the data, we recall the relevant formula and after recalling the relevant formula, we apply the values and after the simple calculation, we get the answer. So let's see the rough work here. So we write down here from question it is clear that m equal to 14.5 kg and L equal to 1 meter and omega equal to 2 rotation per second and cross sectional area of the wire which is generally denoted by A is 6.5 we write down here when decimal move in the right hand side 2 digit then it will be 6.5 into 10 to the power minus 2 and when centimeter converted into meter then also we divided by 100 then we get 10 to the power minus 4 meter. So 1 2 3 4 items are given in this question and ask us calculate the elongation of the wire when the mass of the lowest point of its path. So in this question ask us what is the value of del L. So we draw a relevant figure according to the question. Suppose this is a center and in this circular path uh, this mass is hurled by the steel wire. So according to this direction. So at this point the mass experience a gravitational force as well as the centripetal force. The value of the centripetal force here will be mv square by r and value of gravitational force will be mg. So the total force will be addition of these two. So this is the v is the linear velocity and we know that the relation between linear velocity and angular velocity that is the linear velocity equal to angular velocity into radius of the circular path. So here we get m and when we square this one then we get omega square r square. So omega square r square divided by r then we get here m omega square r. So this is the centripetal force and this is the gravitational force and these two force clear the force which is acts at this point. So we this question is based upon the Young modulus. We recall Young modulus is generally denoted by Y. So we write down here Y equal to force by area into this one is the stress by a strain. A strain is the del L by L. So this one will be F L by A into del L. So here del L will be del L equal to F L by A into Y. So from the table we see the Young modulus of the steel wire, and the value of L is given, and we find out addition of these two gravitational force as well as the centripetal force. Then we get the value of F. The value of A is given. After the simple calculation, we get the answer of this question or solution of this question. However, there is no problem to understand the rough work of question number 8.11. Let's see the fair work or fair solution of this question. So this is the question number 8.11. Let's see the solution. From question it is clear that so the value of M is given here. M equal to 14.5 kg and L equal to 1 meter, and angular velocity omega equal to 2 revolution or rotation per second, and cross sectional area which is generally denoted by A is 0.065 centimeter square, which will be equal to, in a standard form, 6.5 into 10 to the power minus 2 divided by 10 to the power 2 meter. So in the single line it will be 6.5 into 10 to the power minus 4 meter. After there is no problem to understand up to this step. Let's draw the relevant figure. So the here relevant figure will be, let's see, this is the circular path. So in this circular path, at the bottom, length of the steel wire is 1 meter. This is the centripetal force, and here gravitational force. So this is the mg, and this one will be m omega square L. Already in the rough work I have discussed this one. So total work force will be mg plus m omega square L. Now we recall Young modulus to find out the elongation. So we write down here, we know that So we recall the formula of Young modulus, which is generally denoted by y equal to f into L by, here will be del L into A. Hope that there is no problem to understand up to this step. In this question ask us what is the value of del L. So here let's see, del L will be, so del L equal to f into L by A into y. So this formula will be used to find out the value of del L. So we write down here. Now putting the value of, now putting the values of f, L, A and y. So we write down here del L equal to the value of f. We find out the value of f equal to mg plus m omega square L into L is 1 meter by, here will be 6.5 into 10 to the power minus 4. And let's see the Young modulus of the steel wire from the table which is given in the textbook. So let's see where is the table. Young modulus of the steel wire. So let's see here. Young modulus of the steel wire is 200 into 10 to the power 9 Newton per meter square. So it will be 2 into 10 to the power 11 Newton per meter square. Let's see the solution here. So here we write down here 2 into 10 to the power 11. The value of m is 14.5. We write down here 14.5, and the value of g is 9.8. Again we write down here 14.5 into the value of omega is 2 square, and the value of L is 1 into, we write down here 1 by, here will be 6.5 into 2 into 10 to the power 11 minus 4 equal to 7. After that, there is no problem to understand up to this step. So let's see here. Your next step will be, we take 14.5 common, then 9.8 plus 4 will be 13.8, and here will be into 1 by 6.5 into 10 to the power 7. So the after simple calculation get here we 1.539 into 10 to the power minus 4 meters. So this one will be the answer. Of that, there is no problem to understand the solution of this one. If you have any problem, write into the comment box. Let's see the question number 8.12. So let's see the question number 8.12. Compute the bulk modulus of water from the following data. Initial volume, it means that V1. Pressure, it means that stress 100 atm. When this one is multiplied by 1013 into 10 to the power 5, then this one we converted into Pascal. Final volume equal to V2. Compare the bulk modulus of water with that of air at constant temperature. Explain the simple term why the ratio is so large. So in this question ask us what is the bulk modulus of water. So we know that B equal to, or bulk modulus equal to a stress. A stress is just equal to the pressure. So we write down here pressure by volume strength. So volume strength equal to del V by V. So we write down this one. So here will be P V by, we write down here del V equal to V1 minus V2. After the simple calculation, we get the value of bulk modulus. Let's see the fair work. So let's see the question number 8.12. Let's see the solution. From question it is clear that first of all we prepare a data. So we write down here V1 equal to here V1 is 100 liter. So we write down here 100 liter, and we convert this liter into cube meter. Then this one will be 100 into 10 to the power 3 cube meter, and V2 equal to 100.5 into this one will be 10 to the power 3 cube meter. And here pressure equal to, let's see, 100 atm 100 into 1 point, let's see the value of 1 atm equal to 1.013 1.013 into 10 to the power 10 to the power 5 Pascal. So we recall the bulk modulus formula. So we write down here. We know that volume state. So this one will be, and this one will be P V1 by V1 minus V2. Now putting the value of P V1 and V2. So we write down here the value of P, or bulk modulus, equal to the value of P. Let's see here. The value of P is 100 into 1.013 into 10 to the power 5, and the value of V1 is 100 into 10 to the power minus 3 by the value of, here we write down here V2 minus V1. So the value of uh, V2 is, let's see here, 100.5 into 10 to the power 3 minus 100 into 10 to the power 3. So the here next step will be, this one will be 10 to the power 2, 10 to the power 2. So this one will be 10 to the power 4 uh, plus 5, 10 to the power 9 minus 3 equal to 10 to the power 6. So here will be 1.0, we write down approximate. So 1.013 into 10 to the power 5 to 7, 7 to 9, 9 minus 3 equal to 6. where here we write down, we take 10 to the power 3 common into 105 minus 100 equal to, here will be zero point 0.5. So here will be 1.013 into, here will be 10 to the power 6 and 10 to the power 3, so we write down here 10 to the power 3 by 5 into 10. After there is no problem to understand up to this step. So the here when this one is multiplied divided by 5, then we get point 0 and 0, and here will be, let's see, when 1.013 divided, or we write down here for we remove the decimal here, then we get 1 into 10 to the power 1 to 3. This one cancelled out, then we get here 1.01013 by 5 into 10. So this one will be 5 to the 10, and here will be 0, 5 to the 10, 3, so 0.56 is 30 into 10. When this decimal move in the left here, then we get 2.02 into 10 to the power 3. So what is the value of this one? So this is the bulk modulus. So here will be B equal to 2.02 into 10 to the power 3 Newton per meter square. So this one will be the answer of this question. Similarly, we can solve rest questions of this exercise or chapter. Hope that this class will be useful to the schooling students of class 11 having a subject physics. In the next class, I will try to solve rest questions of this exercise. Till then, thanks to all of you.